Hey.
So Bassem, I hear you've got a bet.
Yeah. So after lunch one day or 2 days ago, I was talking with a PhD student at QTech, and he showed me this paper that um, so a quantum channel is a map from a quantum state to another quantum state, and the input dimension could be different from the output dimension.
Okay.
So he showed me this paper that says that there exists channels that cannot be decomposed into two smaller channels if you fix the input dimensions of each. And then we discussed afterwards whether this applies if we change the input and output dimensions. So can you find a channel that does not allow this decomposition if you allow the dimensions to vary?
So what does it mean for a channel to be decomposed?
Um, okay, so a channel, you can think of it as a, a transformation on a quantum state. So if you take a quantum state and you let it evolve in time, something happens to it, then it has passed through a quantum channel. And to decompose a quantum channel into two quantum channels means to say that first this happened, then this happened, and then you get this output quantum state.
So it's a sequential
Yeah.
decomposition.
So the theorem says that some quantum channels do not allow for this. You cannot divide a quantum channel into first this happened and then this happened if you fix the input and output dimensions.
Right, it all has to happen at once as a single
Yeah.
process. Interesting.
But I claim, or at least it's intuitive to me, that this does not hold if you allow the output dimensions and input dimensions to be different. And I bet him that I was going to prove it by next Monday. Not this Monday, the one after next.
Right, so you're attempting to prove that you can decompose a channel provided the input and output dimensions are different.
Yeah.
Right, so one obvious way in which you could lose the bet is the result is false.
No, actually, so if I can prove it either way,
Ah,
then I get the money. It's €5. Yeah, so if I could prove that any channel can be decomposed like this, or if I prove that there exists channels that cannot be decomposed like this, then I win. So the assumption here is that the proof is going to be hard.
so if you prove that it can't be decomposed even if the dimensions are different, then you've extended the result of this paper.
Yeah.
So what drew your attention to this paper in the first place?
Yeah, I don't remember what we were talking about, but he mentioned this as a counter argument to what we were discussing. And then he said that this is surprising to him, that some channels cannot be decomposed. And I said that it might be surprising if you allow the dimensions to vary, because channels in general have different input and output dimensions. But he said, no, it's surprising even with fixed dimensions. And I didn't see why. So I said, um, okay, I'm going to show that it's not that surprising, because in general you can divide any channel that way if you allow the dimensions to vary.
Are you going to try and prove it first or find a counterexample?
Prove it, because yeah, my guess is that it's true.
And what gives you confidence that it's true?
Because if you think of a quantum channel as a physical process that the quantum state goes through, then you can divide it into sub processes always. Yeah, maybe my intuition is naive. I'm not sure, but it's my intuition that because it is a physical thing, then you can divide it into infinitesimally small physical processes that will give you the output process, like the big process.
And how do you intend to go about proving it?
First, I'm going to read the paper, understand it pretty well, and I had a chat at lunch with some other PhD students on how to approach this, and they mentioned that linear algebra is probably the best tool, and thinking about the convex cones of quantum states. Yeah, so I'm right now I'm relying on this urgency that I have to find a proof before next Monday, and yeah, so if I have to go, yeah, so if I have to, I even look into um, encoding quantum states as inputs to Turing machines and finding something that the Turing machine does or something like that.
Do you have an intuitive idea, at least, about how the proof might go?
Mm-hmm. Mm, No, all I have is an approach. So I will think about it as a physical thing. Like a quantum channel is a physical thing. It's a process that happens to a quantum state. So what does it mean that you cannot divide it into two processes? What does that mean? And maybe then I will be able to understand why any quantum state can be divided into two if you allow the dimensions to vary.
So your ideas come out of physical intuition first, and then you might try and represent them mathematically.
Yeah, I think so. So I think this is interesting because this could be, for example, a master's question or something. And the PI would expect the student to take 6 or 7 months to answer. But I think some questions can be answered more quickly if we don't expect that they will take long. If we just it's a question, it's probably simple. Let's do it now, and not be afraid that it's going to take long, and maybe let's wait for a master student to do it. Then I think many questions are skipped because people think they're going to take so long. So I will seriously try to prove it by next Monday, and so I'm thinking if I should take it. Yeah. So how I should approach this seriously, or should I take it too seriously, or should I not stress my mind too much? I'm not sure.
Some scientists have had success by working intensely over a number of days without much sleep, and then they can get a eureka moment after sleep.
Okay, yeah, I'll try that. But I have limited time, so I have to decide on a strategy. Yeah, if I could, I would crowdsource this. How should I approach this? Like throw it on the internet and see what people would say. How should I use my time most efficiently?
But there's not enough time for that.
Missing. Yeah, probably not. So I think I'll just work hard, keep it running at the back of my mind when I'm resting, and see what happens. Yeah.
And what's your plan after reading the paper?
So they proved that if you fix the dimensions, there are channels that can be decomposed or cannot be decomposed. I'm going to try to find the part in that proof. So how could they show the existence of a channel without explicitly giving that channel? Because I don't know. I will try to find how they did it, like the specific part in the proof where they did it, and then see if I can use it again to show the same thing if we allow the output-input dimensions to be different. And if I can't, then it's going to be wild from there. I don't know what I'm going to do. I'm going to see.
Are you allowed to ask the PhD student?
Yeah.
What's the likelihood of him helping you?
Pretty likely. He has no reason to obstruct my progress. Like he would be interested to know the answer to that question, even if he's going to lose €5.
Is €5 enough to keep you motivated?
Yeah, I think so. It's a symbolic thing. So yeah.
Do you have plans for future bets?
Yes, I like this bet because it really made things interesting. So I guess if you place the bets, if you do bets properly, then you will get motivated to answer questions like these, and you will minimize or you will reduce the number of questions you throw away as would take too much time to answer. Yeah, then if a bet gets me to do that, that will reduce the number of questions I throw away, and that's good.